Okay, good day. Assalamualaikum. And today I'm going to talk about the second chapter in Bitg 1233 for computer programming. So let me share my screen. All right. So this is chapter is entitled Problem Solving with Programming, I suppose. And the learning outcome for this particular chapter is that at the end of this, you should be able to appreciate programming as a tool to solve problems. So there are many problems that require calculation, especially repeated calculations that are complex and you have to do it repeatedly. So by using programming, I guess that's helped you in solving that problem. Then explain the system about software or program development methodology, describe the steps involved in problem solving, identify the input, the process and the output of given problems, identify and apply basic problem solving design techniques to design algorithm in solving problems. Okay, and that by using flowchart and pseudocode. So flowchart and pseudocode are something that you need to be able to do because it is something you are required to use, especially including during tests and things like that. So let me apply something there. How about that? All right. Let me save that real quick and it should be good. So programming and problem solving, what does problem solving have to do with programming? Everything. Programming is about problem solving. Yes, engineers and scientists are problem solvers. What a good problem solver does is often ask more questions. It's good to ask questions. Okay, so first of all, before you solve the problem, you got to understand the problem first. Then only you know what to solve first. And my professor used to say, especially we in engineering, we always need to find what are the governing equations. What are the governing equations that we need to use in order to solve this problem? Okay. Once you identify the correct equation that can help you solve that problem, and then there's already half the battle in solving the problem. Might not be in equation, maybe a procedure, or steps or SOP. You must identify the correct procedure instruction to follow, things like that, or steps. Then only you can try to look into how to apply that in solving your problem. When you solve a problem, the level of abstraction that you choose to look at can influence how easy or hard the problem is to solve. Abstraction, that's a big word. You got to find out what it means. Because some problems is open-ended and it's up to you to make it as simple as you want or as complicated as you want. Solving a problem can involve moving between this level of abstraction, more detailed, less detailed. So you choose, or maybe your client has to choose and things like that. You try the best you can, get an answer, and then try to improve. Always strive to improve. Okay, that's cool advice. Whenever you have to solve problems, especially big, hard ones, difficult ones, the rule is never to give up. You have to keep on asking the more question, hopefully the right question, and then break the problem into smaller chunks, smaller subunit or parts, divide and conquer kind of thing. So if you can solve especially if you find it very daunting and too many calculations to do. So you get to, or you identify that the final answer is incorrect. So try to start little by little, start from the beginning. Maybe a few steps first, solve the first equation first, see where the problem might lie, where you went astray, things like that. Think of the benefits and profit that you'll get. And then the last one, as soon as you develop one solution, start thinking of another way and just don't settle with what you've got until you can think of other solutions. This is the most important quality of a problem solver. So always do improvement, especially if you still have the time. If you, in the context of programming, maybe you do it in the long way because you are being very meticulous and you are trying to be very careful. But then after you have done, you got the right answers, try to look into ways to simplify things. Maybe make it shorter and see whether you still get the right answer in the end. Then programming is also a creative process, just like cooking. You got to use creativity. There's no hard and fast rule. You got to do it this way on highway, do it my way or highway. But some ways are better than others. Some ways are easier than others. The programming process critically determines the overall quality and success of the program. Therefore, in the programming process, there is the outline of the plan, methodology to follow. Okay, so a lot of our work, we got to be methodical. It's not trial and error. If possible, look into, is there a recipe? Is there an SOP for us to follow? If not, do we have to create our own solution steps for this? So that might, you have to dig into your experience and things like that. So these are the things. Most programming projects are built using a software development lifecycle methodology, or SDLC, software development lifecycle. If you have taken engineering design, it's kind of something similar to that. Okay, so with some tweaks here and there. So the same thing, you want to develop something, it's kind of like you want to design something. Even if you want to design a recipe for cooking, want to make a new meal, you can follow the same step that you learn in engineering design. One of the popular models in SDLC is known as the waterfall model. That is something new to me, so perhaps something new to you too. Okay, here's the waterfall, very nice looking waterfall. So always start with knowing the problem. Knowing the problem involves software requirements, or like us in the engineering as PDS, product development specification, product design specification, PDS. So it's kind of like this software requirements. And then you got to do some analysis. You got to do some design. And then once you, maybe the meaning of over here is a bit different from what we do in mechanical engineering. But then you proceed to doing the coding. You have to actually do the code, write the code, and then you have to test run your code, your program, to see if the solution that you get is satisfying. And then you do some maintenance, how to maintain that system. And it is a loop, so you can go back and forth between the step, each of the steps. Then you can cluster it, like analysis and design is the problem solving phase, coding and testing in the implementation phase. Okay, so yeah, you got to follow the phases. You got to plan your work, otherwise things can be like helter-skelter or unplanned, unorganized, unorganized. And that kind of mistake would probably cost you a lot more time in order to complete the job. All right, and then programming process. Two major phases with 4 steps of processes. It requires you to do the following. Okay, let me bring this a little bit down. And then problem solving phase and implementation. Okay, just like from that figure before this. So analysis is step 1, and then the design is step 2 in the problem solving phase. The result is an algorithm that solves the problem. Okay. And then the implementation phase involves coding. So you actually write the codes line by line. And then testing it to see whether you get what you expect to get. Or you have to see if whether the quality of the output is acceptable. To produce the program, we may use different programming approaches. Procedural programming is a programming approach that focuses on the process. When procedural programming is used to solve big problems, it uses top-down design. So something you start from the head and go down. A big problem is divided into smaller sub-problems. Okay, that's understandable. And then the solution of sub-problem actually involves a test or some tests that are grouped as a module or sub-module and are coded into a function or functions, many functions of the program. Okay. Yes, especially if you involve a lot of calculation, and that calculation seems to be repeating at different locations. So it's better to have that calculation done as a function. And then step number 1, analysis. So this is going to the details. So you have to, this is part of understanding the problem. Clearly define what is needed in the input, process, and output IPO to solve the problem. IPO means input, process, and output. If solution requires top-down design, then draw a structure chart. So that contains the hierarchy of modules in the solution. So this is the top-down design. So you have the main module or main program, And then you have the sub-product program. We call it module 1, module 2. And then we can further break it into sub-module, into sub-modules. Okay, the second part of the implementation is design the algorithm to get the logical step of achieving the problem solution. Algorithm is a set of well-defined and precise instruction or steps of procedure, SOP, that finally leads to the solution. Algorithm design to determine how to take inputs and process them into the specified output. So you must also relate this to what are the equations that you probably need to do. And then once you have identified that, so you try to ascertain which part, what kind of information that is needed to solve that equation, to use that equation. Okay, so what are the variables? You give them the names of the variables, and you decide how that variables will get the data, either by asking the user for input, you have to, the program needs to read from certain files and things like that. Algorithm must be tested for its correctness, no logic errors. Experience shows that this saves time in getting your program to run correctly. Do corrections to the algorithms design as many times as necessary, as long as there's still logic error in the algorithm. So logic error is usually you as the user must be able to detect, especially if you try it with something that you know the answer. If the answer given is off, so you try to find how to get that to release or to achieve the correct answer. Okay, so when we say about algorithm, the steps can be shown or designed or constructed using two approaches. Number one is pseudocode, and number two is flowchart. Precise, okay, pseudocode is a precise algorithmic description of programming logic. Its purpose is to describe in precise algorithm detail what the program being designed is to do. Number two, requires the defining the step to accomplish the task in sufficient detail so that they can be converted into a computer program. Okay, so pseudocode. Usually, you use high-level human language to kind of like tell people or tell your boss what are the steps that you are going to do. So you are trying to tell the computer what to do first, and then second, next, what the computer needs to do, and so on and so forth. But in your own language, so you don't have to use the computer syntax, the grammar of the C++ yet. Similarly, we can also show that steps using flowchart. A schematic diagram representation of a sequence of operators in a process. Program flowchart show the sequence of instruction in a single program or subroutine. Different symbols are used, especially the boxes, to represent different operations in a flowchart. These arrows are used for direction, and then this second one below the arrows is terminal. It's for usually for begin or start and also end. Then wherever you have decision to be made, you use the diamond. Pause here a little bit. How do I pause the? Yeah. Okay. And then you have these connectors. Then this one is for preparation. So usually we use this regular box or rectangular box for process. And then we have input output shown by this rhombus. And then call to function, predefined process. So you can use this kind of box. Okay, for coding, the actual coding programs and algorithm that has been expressed in the programming language. Now you are starting to talk to the machine. The coding process is easier as you gain experience with the programming language. Correct any syntax error, especially if you forget semicolon, or maybe you misspell the instruction or the command. So try to identify that and do the necessary corrections. And then keep on correcting as many times as necessary until there's no more syntax error. Usually it's easier than some of you might expect. Okay, test the program, run it, compile it as many times as necessary to validate the result, especially you know, try to get to know what are the limitations so that you using the program in the correct manner. Then correct any runtime or logical errors if found. Okay, problem solving examples. Your summer surveying job requires you to study some maps that give distances in miles. You and co-worker prefer to deal in metric measurements, kilometers. Write a program that performs the necessary conversion. The program will display the distance in kilometers. So, yep. So what are the steps for this? The first step is to analyze, do some analysis, highlight the problem statement. Okay, so the first one, maps that give distances in miles. So your map is in miles. And what you want to do is to convert the miles to metric, kilometers. So you want to create a program that does that conversion. So identify IPOs. input, process, and output. So the input must be distance is in miles, whereas process include formula. So you need to find or identify the correct formula or equation. Yep. And then output, the distance, you have to display the output in kilometers. So if you want to draw the structure chart using a top-down design approach, so the main box will be, the first box will be conversion problem. Then that is broken into input, output, and lastly display. So this will be the structure chart. If you want to use a pseudocode to solve this, we'll follow this example. So number one is start, number two, call function input, read distance in miles. So and then return M, hopefully okay, return M. So you remember what M is. Then the third one is call function convert. Yes, I mean call function to convert. The first one is to calculate the distance in kilometers using that k equals to m times 1.6, and then return that value k or that variable, and then call function display. So you want to display what k is in kilometers. Okay, finally stop. So this is pseudo code in human language, in high level language. Okay, so this is the algorithm shown in so this algorithm is shown in flowchart using the correct box. So when you use this box, it means this is one sub function, maybe function. One function to convert is one function, and to display is another function. Okay, can also so this is for input process. So start with the input, read the distance in miles, return m. To convert, so this is the second function. You got m as the input and do that calculation and then return k. And for the final one, display k. So k is already stored in the previous function, and then we pass it to this last function, and then we just display it and then return. So we can try this program, this code, and see what it will deliver. So always start with hashtag include. Usually IOStream. Then the second line using namespace std semicolon. Then we have double input, void display. Then convert is of a double type. Double type. Okay, so we can do this thing line by line. So in the first, so this will be the main body, main function. Down below it, down below the main body, we can have this first function. It's called input. It will check the so this one will ask, please enter distance in miles. So you have to wait until the user supply that value, and we call this C in miles, and then we return this value miles. Then for double convert, so this is another function. So it will convert the miles here into kilometers. Okay, so the equation is this one. K equals to m times 1.609. Then we'll return this value. Okay, and the last one will be to display. So this is another function. So we'll just display the C out using C out. Distance in kilometers is, then the C out distance in kilometers. Then you go one step below or enter. So all right. So step one in the analysis, you want to get the distances from a map and then convert them into somewhere into kilometers, sorry, into kilometers. Then you do the IPOs, input, process, and output. Okay, basically you can follow these steps. And for that exercise, we can do the planning either in using flowchart. The flowchart will be something like this. So getting the information, we'll use this skewed box, getting the input value, and then do the calculation. This is a process, use a regular rectangle. Then to display it, use another skewed kind of like rhombus or something like that to display or giving the output, then stop. And on the left here, we have a pseudocode. So basically using human languages, and we pretty much write what is supposed to be done, but in using not using the C++ language, but rather using human language. So and then doing the actual coding, so you can do like this. Then I guess you can copy this thing and try to run it in the editor. In this case, distance is 4.5 kilometers, and that is equivalent if you convert 4.5 miles, 4.5 miles, and that is equivalent to 7.24 miles. Sorry, 7.24 kilometers. 4.5 miles equal to 7.24. Write a program that inputs two integers, n1 and n2. So n1 and n2 are the variables, and then calculate and print out the value of n1 and squared and n2 to the power of 3 cube, n3 cube, and n2 cube, n1 squared and n2 cube. All right, so the first step in the analysis is to plan, to do the analysis. Okay, so here is showing the steps. Input, we need to get n1 and n2, the values for this. And then for the process, what is the calculation needed to be done, to be carried out, and then you just output it. Answer 1 and answer. These are the flowchart and pseudocode for that problem. And if you run this thing, on the left is the code. Okay, you can copy this thing. Yes, so. So maybe from your PDF you can do it, and then run it, and you should get 7 and 9. And these are the answer or the output from this program. 49 and also 729. So step 1, analysis. So this is probably a different problem. Ohm's law is often expressed in the form of V equals to IR. V is the voltage measured in volts, and I is the current measured in amps, and R is the resistance. Write a program that can calculate how much current I would flow through an input ohm of resistor R if you were to connect the resistor to an input volts in power supply V. However, you need to check for the input volts of the power supply if it is greater than 10 volts, and don't calculate the current if you just if it is greater than 10 volts, don't calculate the current. If you just print out a message, the volt is too big. If the voltage is less than or equal to 10, if the voltage is greater than 10 volts, don't calculate the current. You just print out a message. The volt is too big. If the volt is less than or equal to 10 volts, calculate and print the current I. And if the volts are negative, print out message not valid input. All right, so these are analysis by understanding the problems at hand. So we need to identify the IPO. So input will be V and R, resistance and voltage. The process include the formulation. If V equals or greater than 10, print message, the volt is too big. Okay, it's kind of sleepy in this afternoon. And for that same problem, can come up with a pseudocode to start, and then you get the data all in human language here, V and R. Then if the voltage is less than greater than 10, write this message, else less than 0, not valid input. And then else if it is less than 10 or I is equal to, if it is less than 10, that means I equal to VIR. Okay, so same thing can be said about this flow chart. Okay, so this is where decision must be made, and then you can print the output. Another decision here, if it is less than 0, and then another last decision is if V is less than or equals to 10. So this will give us I equals to VR, V over R, then we just print. So this is another set. I guess you can copy this thing and try to run it in on your computer, and you should get this thing. Enter V6, enter R 300. This should give us an I of 0.02. Okay, so and so forth. So we are at the end of our lecture. So by now you should be able to describe the first step to take when creating a program. List the two main phases of the programming process. So that involves what analysis and where is that? So I guess that this one. So we have the two phases of problem solving phase and implementation phases. So at the end here, we must know those kind of things. Then list two main phases. Okay, explain the importance of the problem solving phase. Then list the steps for the software development lifecycle. Okay, so try to get the answers to all this. Probably this will be good question for the test and also the final exam. Okay, so this is another example, and I guess that's about it. So in our next lecture, I will try to look into actually using C++ and try to run some of these things so that we can see the practical, because we don't want if this code works on some professor's machine, might not work on your machine, but if they follow the same standard, I guess it should be able to run in any machine that has C++ on it. Okay, I guess we should stop my sharing here. I guess that's a good place for us to stop for this lecture number 2. And I'll see you guys in lecture number 3 after the Ideal Fitri break. Assalamualaikum. Have a good one.